The point is not to provoke concern, but to expand perspective. The world is richer, more layered, and more active than direct experience suggests. Light is not just what you see. It is what structures environments, regulates systems, and connects distant events. Visibility is a local detail. Invisible light remains present, not as a separate category, but as a reminder that the universe operates across scales and ranges far beyond immediate perception. Once light is understood as something that moves, carries energy, and connects events, it becomes impossible to ignore the way it interacts with the very ideas of time and space. Not as background concepts, not as abstract containers where things happen, but as participants. Light does not simply travel through time and space as they already exist. It helps define what time and space mean in the first place. This realization did not arrive all at once. It emerged slowly from small inconsistencies and uncomfortable observations, from experiments that refused to behave as expected. At first, time and space were treated as stable stages. Things happened within them, but they themselves remained unchanged. Light moved across space. Events happened in time. Everything seemed neatly separated, but light did not cooperate with that separation. One of the first clues came from something deceptively simple. No matter how fast the source of light moved, and no matter how fast the observer moved, the measured speed of light remained the same. This was not just surprising, it was deeply unsettling. Every other kind of motion behaved differently. If you ran toward a sound, you encountered the sound waves sooner. If you chased them, they seemed slower. Light did not behave that way. This stubborn consistency forced a choice. Either the measurements were wrong, or the assumptions about time and space were incomplete. The measurements were repeated, refined, and confirmed. The assumptions had to give way. What emerged was a new understanding. Time and space were not independent, absolute entities ticking along in the background. They were intertwined, flexible, and influenced by motion and gravity. Light sat at the center of this realization, not because it caused the changes, but because its behavior revealed them. The speed of light became more than just a number. It became a structural limit. Nothing carrying information or energy could exceed it. This was not a technical constraint. It was woven into how cause and effect operate. Light set the pace at which the universe could communicate with itself. This immediately linked light to time. If there was a maximum speed at which information could travel, then simultaneity could no longer be universal. Two events that appeared to happen at the same time to one observer might not appear simultaneous to another observer moving differently. There was no single global now. Light exposed this quietly but decisively. Because signals could not travel faster than light, different observers could not agree on the timing of distant events without accounting for their own motion. Time became relative, not subjective in the everyday sense, but dependent on physical circumstances. This dependence is subtle in daily life. At human speeds and distances, the effects are tiny. Clocks tick almost in unison. Lengths appear stable. Time feels shared. But the structure underneath is different from what intuition suggests. Light forces time to behave differently for different observers, move faster, and time slows down relative to someone at rest. This is not a psychological effect, it is physical. Clocks carried on fast-moving objects tick more slowly than identical clocks left behind. This has been measured directly. Light is involved because it defines the framework within which motion is measured. The rules governing light's speed require time to adjust so that the speed remains constant for all observers. Space adjusts as well. Lengths contract in the direction of motion. time and space bend just enough to keep light consistent. This adjustment is not something light does actively. It is not pushing or pulling on time. Rather, the laws that govern light reveal that time and space are not rigid. They respond. This response becomes even more pronounced when gravity enters the picture. Massive objects do not just attract other objects. They affect the flow of time and the structure of space. Light moving near a massive object follows curved paths. Its frequency shifts. Its timing changes. This means that light does not simply pass through gravitational fields unchanged. It responds to them, and in doing so, it carries information about them. When light climbs out of a strong gravitational field, it loses energy. Its frequency decreases. This effect, known as gravitational redshift, has been observed and measured. It tells us that gravity affects time itself. Clocks deeper in a gravitational field tick more slowly than clocks farther away. Again, light is central. Because light carries energy and frequency, changes in its properties reveal changes in time. Light becomes a probe of temporal structure. This leads to a remarkable conclusion. Time does not flow at the same rate everywhere. It depends on motion and gravity. Light does not cause this variability, but it makes it visible. Space, too, reveals its flexibility through light. When light passes near massive objects, its path bends. This bending has been observed in eclipses, where starlight passing near the sun appears displaced. Space itself is curved, and light follows those curves. This curvature is not a force acting on light in the usual sense. Light always travels in the straightest possible path within the geometry of space-time. If space is curved, the straightest path is curved too. This idea challenges the notion of straight lines as absolute. What looks straight depends on the structure of space. Light traces that structure faithfully. Because of this, light becomes a kind of ruler and clock combined. By observing how light travels, bends, and changes frequency, scientists can infer the shape of space-time. This is not a metaphor. It is a practical method. Entire fields of astronomy and physics rely on light to map gravity, measure distances, and track the expansion of the universe. For example, the expansion of the universe itself is observed through light. As space expands, the light traveling through it stretches, its wavelength increases, its frequency decreases. Distant galaxies appear redshifted not because they are moving through space like debris in an explosion, but because space itself is stretching between us and them. Light carries that stretching in its structure. By measuring the shift, we learn about the history and rate of expansion. Here again, light is not passive. It does not merely reflect what is already known. It encodes changes in space-time within its own properties. This encoding happens automatically. Light does not need to be aware of gravity or expansion. It simply obeys the rules, and those rules tie its behavior to the geometry of the universe. At this point, the phrase, "light touches time and space," becomes more literal than poetic. Light interacts with the deepest structures that define reality. It is sensitive to motion, mass, and geometry. This sensitivity has practical consequences even close to home. Technologies like GPS rely on precise timing. Satellites orbiting Earth experience different gravitational conditions and speeds than receivers on the ground. Their clocks tick at different rates. Light signals exchanged between satellites and receivers must account for these differences. Without corrections based on relativity, GPS systems would drift rapidly, producing errors of kilometers. This means that everyday navigation depends on light's relationship with time and space. What seems abstract is quietly operational. Light also defines causal structure. Because nothing can travel faster than light, there is a limit to what can influence what. Events outside each other's light cones cannot affect one another. This structure shapes what kinds of interactions are possible. The idea of a light cone is a way of visualizing how light links events in space-time. From any event, light can travel outward, defining a region of influence. Inside that region, cause and effect are possible. Outside it, they are not. This structure gives time direction and order. It ensures that causes precede effects. Light enforces this not by choice, but by being the fastest messenger. Without light's finite speed, causality would lose its structure. Everything could influence everything else instantly. The universe would behave very differently. Light's role here is not optional. It is foundational. Even at the quantum level, where time becomes more ambiguous, light remains a reference. Quantum interactions propagate at or below the speed of light. Entanglement correlations may appear instantaneous, but they do not allow information to travel faster than light. Causality remains intact. This consistency across scales reinforces the idea that light is woven into the framework of reality, not layered on top of it. When asking what light is made of, this becomes relevant in a subtle way. Light is not just something within space-time, it is part of how space-time reveals itself. Photons carry energy and momentum, but they also trace the geometry of the universe. They follow its curves, they respond to its stretching, they reveal its structure. This dual role makes light unique. It is both actor and witness. Time, as experienced by humans, feels like a steady flow. But light reveals that flow to be variable. It stretches and compresses depending on conditions. Space feels solid and fixed. Light reveals it to be dynamic and responsive. These revelations do not invalidate everyday experience. They sit beneath it. At human scales, the effects are small enough to be ignored, but they are always present. As you sit now, light from the room reaches your eyes. That journey took time, even if the delay is too small to notice. Gravity shaped that journey, even if the curvature is negligible. Motion matters, even if relative speeds are low. Everything that makes this moment possible depends on light interacting with time and space in consistent ways. This interaction does not demand attention. It happens quietly, continuously, without drama. But it reshapes how reality is understood. Light does not merely exist in time, it helps define it. Light does not merely occupy space, it reveals its shape. This makes light less like a substance and more like a structural element, a thread that stitches together events, distances, and durations. When light is spoken of as energy, the word can feel vague, almost interchangeable with usefulness or power. We talk about having energy, lacking energy, conserving energy, without always stopping to ask what the word actually means in a physical sense. In physics, energy is not a feeling or a resource you carry around. It is a way of accounting for change. It is the bookkeeping system that keeps track of what can happen and what cannot. Light fits into this system in a very particular way. It is energy in transit, energy that does not sit still, energy that refuses to be stored in place without immediately becoming something else. And because energy is tied so closely to how reality behaves, light ends up playing a quiet but central role in shaping what the universe can do. One of the most striking things about light is that it carries energy without carrying mass, at least not rest mass. Photons have energy and momentum, but they do not weigh anything in the way matter does when it is at rest. This alone makes light unusual. Most things that carry energy are also made of matter. A moving object carries kinetic energy. A compressed spring carries potential energy. A hot object carries thermal energy. In each case, the energy is tied to something that can be weighed, held, or pointed to. Light breaks that pattern. It carries energy directly without needing a material container. When sunlight warms your skin, energy has been transferred, but no matter has arrived. When a plant uses light to power photosynthesis, energy enters the system without adding mass. When a solar panel generates electricity, energy flows from light into electrons without anything tangible being delivered. This ability to move energy without moving matter is one of the reasons light is so influential. It allows change to propagate across vast distances efficiently. Stars can affect planets across empty space. Galaxies can influence each other's evolution through radiation. Information and energy can travel without dragging material along behind them. Energy conservation plays a key role here. Energy cannot be created or destroyed, only transformed. When light is emitted, energy leaves one system and enters another. When light is absorbed, its energy becomes something else. Heat, chemical change, motion, electrical current. Light is not exempt from this accounting. Every photon's energy must be accounted for. If light warms something, that warmth comes from the light's energy. If light knocks an electron loose, that energy comes from the photon. Nothing appears from nowhere. This strict bookkeeping gives light a kind of honesty. It cannot cheat. It cannot deliver more energy than it carries. It cannot disappear without consequence. Because photons carry energy proportional to their frequency, light links energy directly to time. Frequency is a measure of how rapidly something oscillates. Higher frequency means more oscillations per second. More oscillations per second means more energy per photon. This connection between energy and frequency is not arbitrary. It reflects a deep relationship between time and change. Faster oscillations correspond to higher energy, because more change is happening in less time. This is one of the places where light reveals the shape of reality rather than just occupying it. The rules connecting energy, frequency, and time are not optional. They are structural. They define what interactions are possible. For example, certain chemical reactions require photons above a specific energy threshold. Below that threshold, nothing happens. No amount of waiting will help. The interaction is forbidden. Above the threshold, it proceeds. This threshold behavior shapes everything from vision to chemistry to biology. It determines which wavelengths of light drive photosynthesis, which damage DNA, which trigger vision, and which pass through harmlessly. These thresholds are not negotiated. They are consequences of how energy levels are structured in atoms and molecules. Light must meet the requirement or be ignored. In this way, light acts as a gatekeeper. It allows certain changes and forbids others. The shape of reality, at the microscopic level, is defined by which energy exchanges are allowed. Light also connects energy to momentum. Even though photons have no rest mass, they carry momentum. When light strikes an object, it exerts pressure. This pressure is tiny in everyday situations, but it is real and measurable. Solar sails take advantage of this. By reflecting light, they gain momentum from photons. Over time, this momentum accumulates, producing motion without fuel. The energy and momentum carried by light-shaped trajectories. This again challenges intuition. How can something without mass push something with mass? The answer lies in the way energy and momentum are related. In relativity, energy itself has inertia. Anything that carries energy resists changes in motion. Light carries energy, therefore it carries momentum. This blurs the line between matter and radiation. Matter and light are not separate categories. They're different manifestations of energy under different conditions. This becomes even clearer when considering the relationship between energy and mass. According to relativity, mass itself is a form of energy. The famous equation connecting mass and energy is not a slogan. It is a statement that mass and energy are interchangeable under the right circumstances. Light makes this interchangeability explicit. In certain interactions, light can produce matter. High-energy photons can transform into particle-antiparticle pairs when conditions allow. Conversely, matter can annihilate into light, converting mass directly into radiant energy. This is not theoretical speculation. It has been observed and measured. In these processes, light and matter are not opposites. They are expressions of the same underlying currency. This means that light is not just energy moving through space. It is part of the fabric of what matter is allowed to become. The shape of reality, in this sense, is defined by transformation rules. Which forms of energy can turn into which others? Which processes are permitted? Which are forbidden? Light sits at the crossroads of many of these transformations. It is produced by changes in matter. It causes changes in matter. It mediates forces. It reveals structure. Because light moves at a fixed speed, energy carried by light has a built-in relationship to space and time. You cannot compress light energy into a smaller duration without increasing its frequency. You cannot spread it out without lowering its energy density. This constraint shapes what signals can look like, how quickly information can be transmitted, and how interactions unfold. It limits how sharply events can be localized in time and space. These limits are not inconveniences. They are stabilizing features. Without them, reality would behave very differently. Cause and effect would blur. Structures would be unstable. The universe would not resemble the one we inhabit. Light also plays a central role in defining temperature. Temperature is a measure of average energy per degree of freedom in a system. Objects at higher temperatures emit more energetic radiation. As temperature increases, the spectrum of emitted light shifts toward higher frequencies. This relationship allows temperature to be measured remotely. By analyzing the light emitted by an object, its temperature can be inferred. This works for stars, planets, and even distant galaxies. Here again, light acts as a translator. It turns internal energy into something that can be measured across distance. The universe cools as it expands, and light carries the record of that cooling. The faint background radiation filling space today is a snapshot of an earlier, hotter universe. Its energy distribution encodes information about the shape and history of reality itself. This means that light does not just respond to the shape of reality, it preserves it. It carries imprints of past conditions forward in time. Even within smaller systems, light shapes structure. Atoms are held together by electromagnetic interactions. Light mediates these interactions. Chemical bonds form and break through energy exchanges involving photons. Molecular shapes depend on energy landscapes shaped by electromagnetic forces. Without light, chemistry would not exist as it does. Without light, matter would behave differently. Structures would not form the same way. Life would not arise. This does not mean light causes everything. It means light participates in everything that involves electromagnetic interaction, which is most of what matters at human scales. Gravity shapes large-scale structure. The strong force shapes atomic nuclei. The weak force governs certain types of decay, but electromagnetism, carried by photons, governs structure, chemistry, and biology. This centrality makes light feel fundamental, but not in the sense of being the smallest building block. It is fundamental because it mediates relationships. When asking what light is made of, the question shifts again. Light is not made of pieces in the way matter is. It is made of energy organized according to rules that tie together space, time, and interaction. Those rules give reality its shape. They define what kinds of patterns can exist, how long they can persist, and how they can change. Light does not sit outside this structure. It is one of the threads that hold it together. As you rest with this idea, it may become easier to see why light keeps reappearing in so many contexts. Vision, heat, communication, astronomy, technology, fundamental physics. Light is present not because it is convenient, but because it is unavoidable. Energy must move. Information must propagate. Forces must act across distance. Light is how much of that happens. This does not mean light is the ultimate substance of reality. It means reality uses light as one of its primary tools. The shape of reality emerges from constraints, speeds that cannot be exceeded, energies that must be quantized, interactions that occur in steps. Light embodies these constraints. The relationship between light and reality remains open-ended. The deeper you look, the less light resembles a thing and the more it resembles a rule set made visible. There is a quiet temptation, once you realize how much light reveals, to assume that it can reveal everything. After all, light shows us distant galaxies, the structure of atoms, the curvature of space, the temperature of stars, the composition of atmospheres, and the movement of time itself. It crosses emptiness, survives vast distances, and arrives carrying information with remarkable fidelity. It feels natural to treat light as the ultimate messenger, capable of telling us anything we care to ask. But light has limits, and those limits matter just as much as its power. Not because light fails or behaves badly, but because information itself has boundaries. Light does not lie, but it also does not speak freely. It only tells what its interactions allow it to tell. Everything else remains silent. One of the first limits becomes clear when you consider that light only reports on what it interacts with. If something does not emit light, reflect light, absorb light, or alter light in some measurable way, then light has nothing to say about it. Entire regions of the universe can remain invisible simply because they do not engage with electromagnetic radiation. This is not a failure of instruments or sensitivity, it is a fundamental limitation. Light cannot carry information about what does not touch it. Dark matter is a clear example. It does not emit light. It does not absorb light. It does not reflect light. As far as electromagnetic interaction is concerned, it may as well not exist, and yet its gravitational influence is unmistakable. Galaxies rotate too fast. Light bends around unseen mass. Large-scale structures form in ways that cannot be explained by visible matter alone. Light reveals the effects of dark matter indirectly, through motion and curvature, but it cannot show dark matter itself. The messenger reaches a wall and stops. Beyond that wall, other messengers are needed. This highlights an important point. Light does not reveal reality directly. It reveals interactions. If there is no interaction, there is no message. Another limit comes from the fact that light always arrives late. Even though it moves extremely fast, it does not move infinitely fast. Every photon you receive left its source earlier, sometimes earlier by fractions of a second, sometimes earlier by billions of years. This delay is not usually noticeable in everyday life, but at larger scales it becomes unavoidable. When you look at the sun, you see it as it was several minutes ago. When you look at distant galaxies, you see them as they were long before Earth existed. Light cannot tell you what is happening right now at a distance. It can only tell you what happened when the light was emitted. The present is always local. Everything else is memory. This means that light cannot provide simultaneous knowledge of distant events. It enforces a kind of loneliness in the universe. Each location experiences its own now. Light connects those nows only after the fact. This is not a technical inconvenience. It is a structural feature of reality. There is no workaround. No better detector can fix it. No stronger telescope can overcome it. Information cannot outrun light. Another boundary appears when you consider resolution. Light has a wavelength, and that wavelength sets a fundamental limit on how finely detail can be resolved. You cannot use visible light to see objects much smaller than its wavelength. The light simply does not interact in a way that preserves fine detail at that scale. This is why microscopes have limits. This is why different wavelengths are used to probe different scales. X-rays reveal atomic structure because their wavelengths are comparable to atomic spacing. Radio waves reveal large-scale structures because they interact over long distances. No amount of clever engineering can bypass this entirely. You cannot force light to reveal details smaller than what its wavelength allows. You must change the light itself. Even then, limits remain. Extremely high-energy photons can probe extremely small scales, but they also introduce new complications. They interact violently. They alter what they observe. They produce cascades of particles that obscure original structures. Light does not offer free access. Every increase in probing power comes with trade-offs. There's also the limit imposed by quantum uncertainty. When light interacts at very small scales, the outcomes are inherently probabilistic. You can predict averages with extraordinary accuracy, but you cannot predict individual events with certainty. This means that light cannot tell you everything about a system at once. Certain pairs of properties cannot be known simultaneously with arbitrary precision. This is not due to poor measurement. It is built into how interactions work. Light carries information, but that information is constrained by quantum rules. You cannot extract more information than the interaction allows. Attempts to do so disturb the system in ways that erase other information. This creates a balance. Light can reveal position, but not precise momentum at the same time. It can reveal energy, but not exact timing beyond certain limits. These are not inconveniences. They are guardrails. They prevent the universe from becoming overdetermined. They allow structure and change to coexist. Another subtle limit arises from interpretation itself. Light delivers raw data, patterns of energy, frequencies, directions, intensities. Meaning is imposed afterward. This means that light cannot tell you what something is in any absolute sense. It can tell you how something interacts with light. Composition, temperature, motion, structure. These are inferred, not directly observed. Even the most sophisticated analysis relies on models, assumptions, context. Light does not carry labels, it carries signals. Understanding those signals requires interpretation. This does not make knowledge unreliable, but it does mean that light never speaks alone. It always speaks through theory. Another boundary appears when light simply cannot escape. In regions of extremely strong gravity, light can be trapped. Once past a certain boundary, light can no longer reach distant observers. Information carried by light is cut off. This does not mean nothing happens beyond that boundary. It means light cannot tell us about it. Events continue, but they are sealed off. This introduces an absolute limit. There are places in the universe that light cannot report on, not because it is blocked, but because the geometry of space-time itself forbids escape. Even closer to home, light can be scattered, absorbed, or scrambled. Dust clouds block visible light, hiding stars and structures behind them. Turbulence distorts signals. Intervening matter alters spectra. These effects can sometimes be corrected for, but not always. Information is lost along the way. Light arrives altered, incomplete. This reminds us that light is not a perfect courier. It is subject to the environment it travels through. It can be bent, delayed, scattered, and transformed. Then there is the limit of perception. Even when light reaches you intact, your senses impose their own boundaries. Your eyes respond to a narrow range of energies. Your brain simplifies, filters, and prioritizes. You never experience raw light. You experience a constructed interpretation shaped by biology and context. Light's message is translated before it becomes awareness. This translation is not neutral. It emphasizes edges, movement, contrast. It suppresses uniformity. It fills in gaps. It creates stability. All of this is useful, but it also means that light alone does not give you direct access to reality. It gives you an interface. Even instruments extend perception rather than replace it. They translate one kind of interaction into another. At each step, assumptions are embedded. There is also the limit of silence. Light only tells us about interactions that occur. It cannot tell us about what did not happen. It cannot report on paths not taken. Possibilities that never became events leave no trace in light. This matters at the quantum level. Many potential interactions exist, but only one outcome occurs. Light records that outcome. The rest vanish without message. This gives light a selective memory. It remembers what happened, not what might have happened. Time compounds this selectivity. As light travels, information spreads out. Signals weaken. Noise accumulates. Details blur. At extreme distances, only the strongest signals survive. Subtle features are lost. The universe speaks more softly the farther back you listen. Even in principle, there are limits to how much information can be extracted from light. Physical laws constrain bandwidth, resolution, and precision. These constraints are not technological. They are fundamental. All of this might sound like a list of disappointments, but it is better understood as a map of boundaries. Knowing where light cannot go tells us where other approaches are needed. Gravity waves, for example, carry information that light cannot. Neutrinos pass through matter almost untouched. Particles reveal interactions light cannot detect. Each messenger has its own domain. Light remains one of the most powerful, but not the only one. This is important for the central question of what light is made of. Light is not a universal key. It is a specific tool. Its composition and behavior define what it can and cannot do. Photons carry energy and momentum. They interact electromagnetically. They obey quantum rules. These properties give them power and impose limits at the same time. Light cannot tell you about everything because it is not everything. It is one way reality communicates with itself, not the only way. Recognizing this prevents overreach. It keeps questions grounded. It reminds us that understanding comes from assembling multiple perspectives, not relying on a single messenger. There is also a quiet philosophical limit here. Light gives us descriptions, not essence. It shows how things behave, not what they are in some ultimate sense. This is not unique to light. It is a feature of all measurement. But because light is so central, its limits stand out. You can analyze light endlessly and still not answer why there is something rather than nothing. Light can tell you how the universe behaves, not why it exists. This does not diminish its value, it clarifies its role. Light is extraordinarily good at revealing structure, change, and relationship. It is less suited to revealing origin, meaning, or necessity. Those questions lie outside its domain. As you rest with this, the idea of limits need not feel restrictive. Boundaries create shape. Without limits, there would be no contrast, no definition. Light's limits help define what kind of universe this is. One where information travels but not infinitely fast. One where observation reveals patterns but not absolutes. One where messengers exist but none are complete on their own. The question sounds simple, almost playful at first, the kind of thing that might be asked half seriously and half as a philosophical tease. Does light exist when no one is watching? It echoes older questions about trees falling in forests and sounds waiting for ears. But when this question is asked about light, it stops being playful very quickly. It reaches into the foundations of how reality is described, how observation fits into physics, and what it means for something to exist at all. At an everyday level, the instinctive answer is yes. Of course, light exists when no one is watching. The sun shines whether or not anyone looks at it. A lamp left on in an empty room continues to glow. Light fills space regardless of attention. Nothing about turning your back makes it disappear. And at one level, that instinct is entirely correct. Light does not depend on human eyes. It does not wait for awareness. It does not flicker into being when noticed and vanish when ignored. Photons are emitted, travel, and are absorbed according to physical laws whether or not anyone is present to care. But the question persists because at a deeper level, light behaves in ways that make observation feel strangely entangled with existence. Not in the everyday sense of needing a witness, but in the physical sense that interactions matter. Observation, in physics, is not passive looking. It is interaction. To understand why this distinction matters, it helps to separate two ideas that are often blurred together. One is awareness, the presence of a conscious observer. The other is interaction, the physical process by which systems influence each other. Physics cares about the second, not the first. Light does not require awareness to exist, but it does require interaction to be defined. A photon is not a tiny glowing bead moving through space with a clearly defined position at every moment. Between emission and absorption, its description is spread out, probabilistic. It is not located at a single point in the way a stone is located on the ground. Its existence during that interval is described by a mathematical object that encodes possibilities rather than facts. This does not mean the photon is imaginary or unreal. It means its reality is not object-like during that phase. It is real as a set of potential interactions. When a photon is emitted from a source, that emission is a real event. When it is absorbed by a detector, that absorption is a real event. In between, there is no fact of the matter about where the photon is, only a set of probabilities describing where it could interact if something were there. So when asking whether light exists when no one is watching, the answer depends on what you mean by exist. If you mean, are photons being emitted, propagating according to physical laws and capable of interacting, then yes, absolutely. All of that happens whether or not there is an eye, a mind, or a detector. If you mean, does light have definite properties independent of interaction, then the answer becomes more subtle. Consider an experiment where a single photon travels toward a screen with two openings. If no attempt is made to detect which opening it passes through, the photon's behavior is described by a wave-like spread of possibilities, and an interference pattern emerges over time. If a detector is placed to determine which opening the photon uses, the interference disappears. The photon behaves differently. This is often misinterpreted as observation creating reality, or consciousness forcing a choice. That is not what is happening. The change comes from interaction, not awareness. The detector interacts with the photon, altering the conditions under which it evolves. The photon does not change because it is being watched. It changes because it is being interacted with in a way that removes certain possibilities. This distinction is crucial. Physics does not require a mind to collapse probabilities. It requires an interaction that makes alternatives distinguishable. Any physical system capable of recording information can play this role. A detector, a molecule, a grain of dust. So does light exist when no one is watching? Yes, but it does not exist as a single, definite outcome until interaction occurs. This may feel unsatisfying if existence is equated with definiteness, but that equation is a habit, not a law. At small scales, reality does not offer definiteness for free. It offers structured possibility. Light exists as a field of potential interactions filling space. It exists as energy capable of being transferred. It exists as a messenger waiting for a recipient. What it does not do is commit to a single story before the interaction demands it. This is not unique to light. Other quantum entities behave the same way. Electrons, atoms, even larger systems under the right conditions exhibit this behavior. Light simply makes it more obvious because it is so familiar and so central. At larger scales, this subtlety disappears. When enormous numbers of photons are involved, interactions happen constantly. Possibilities collapse almost immediately. Definiteness emerges rapidly. A beam of light looks solid. A room looks illuminated. There is no sense of ambiguity. This is why everyday intuition works so well. The world around you is bathed in interactions. Nothing is left in a purely probabilistic state for long. Reality appears firm because it is constantly being reinforced by countless exchanges. But in the quiet spaces between interactions, light behaves differently. If a photon travels through empty space for millions of years before encountering anything, does it exist during that time? Physically, yes. Its quantum state evolves. Its energy remains defined. Its ability to interact remains intact. But there is no event to point to, no record being made, no outcome occurring. In that sense, light exists without happening. This idea challenges the assumption that existence must always be event-like, that something must be doing something to be real. Light shows that something can exist as readiness, as potential, as structure waiting for interaction. This also helps clarify why the universe does not require observers to function. Stars shine without witnesses. Galaxies collide in darkness. Light travels through vast regions of space where no detectors exist. Those photons are not imaginary. They shape environments. They heat dust. They ionize gas. They influence dynamics. Even when no eye sees them, they interact with something eventually. The universe is not paused in the absence of observation. It is active, busy, evolving. The confusion arises because in quantum physics, observation has a technical meaning that overlaps awkwardly with everyday language. Observation means interaction that produces a record. It does not mean awareness, intention, or consciousness. When a photon is absorbed by an atom, that is an observation in the physical sense. Information has been exchanged. A definite outcome has occurred. No mind is involved. This reframing dissolves much of the mystery. Light does not need to be watched. It needs to be interacted with to produce events. The deeper question then becomes whether properties exist independent of interaction. Does a photon have a position before it is detected? Does it have a path? Does it have a definite history? According to the best current descriptions, these questions do not have answers in the way we expect. Not because the answers are hidden, but because the questions are mismatched to the structure of reality. Position is not an intrinsic property of a photon between interactions. It is a property of an interaction. Path is not something a photon carries. It is something inferred after the fact. This does not make light less real. It makes reality less object-centered. Instead of imagining the universe as filled with tiny objects carrying fixed properties, it becomes more accurate to imagine it as filled with processes, interactions, and relationships. Light fits naturally into this picture. It is a process that links events, not an object that persists unchanged. In this view, asking whether light exists when no one is watching is like asking whether a conversation exists before someone listens. The answer depends on what you mean by conversation. The potential is there. The structure is there. The interaction completes it. Light exists as a capacity to interact. Watching, in the physical sense, is what turns that capacity into an outcome. This does not mean that reality is subjective or dependent on minds. It means that reality at small scales is relational. Properties emerge through interaction. At larger scales, this relational nature is hidden by constant interaction. The world looks solid, definite, and independent. But beneath that surface, the same rules apply. Light does not flicker in and out of existence depending on attention. It does not wait for permission. It does not ask to be noticed. It follows laws that allow for potential without commitment. This has an interesting consequence for how we think about knowledge. What we know about light is always tied to how we interact with it. Measurements reveal outcomes, not hidden states. Light tells us what happened, not what might have happened. There is no privileged perspective from which light's full story can be seen all at once. Each interaction reveals one aspect. The rest remain possibilities that never become facts. This does not mean the universe is incomplete. It means completeness does not mean determinacy at every moment. As you sit quietly now, light continues to move around you. Some of it reaches your eyes. Some of it warms surfaces. Some of it passes through walls and bodies without noticeable effect. Most of it never interacts with you at all. All of it exists in the sense that physics requires. None of it requires your awareness. The idea that observation creates reality is a misunderstanding. Interaction creates events. Awareness interprets them. Light exists whether or not anyone is watching, but it does not exist as a finished story until something listens. This perspective does not diminish reality. It makes it more subtle. It allows for a universe that is active, structured, and lawful even in silence. If light exists independently, yet our experience of it depends on interaction, what does that say about our place in the story? Not as creators of reality, but as participants, as receivers of messages that have been traveling long before we noticed them, and will continue long after we stop watching. There is a certain quiet that arrives when questions stop demanding answers and begin to feel more like companions. They do not leave. They simply settle into the background, present without pressure. The question of light, what it is made of, how it behaves, how it connects things across distance and time, eventually reaches that state. Not solved, not closed, just understood enough to stop pulling at the mind. Light, after all this exploration, no longer feels like a thing you need to pin down. It feels more like a condition you are already inside. Right now, light is doing what it has always done. It is moving. It is interacting. It is transferring energy in small, precise amounts. Some of it is reaching your eyes. Some of it is warming surfaces. Some of it is passing through space without leaving any trace that matters to you. None of this requires effort. None of it requires attention. And yet, without light, none of this moment would feel the way it does. Understanding light does not mean holding every detail in your mind. It does not mean remembering equations, terms, or historical debates. It means having a softer sense of how things fit together. A sense that what appears simple often rests on deep structure. A sense that reality can be both precise and strange without being hostile or chaotic. Light is energy, but not energy that stays put. It is made of photons, but photons are not objects you could collect or stack. It behaves like a wave when it moves and like a particle when it interacts, not because it is confused, but because those are the best tools available for describing different aspects of the same process. Light touches space, bending with it. Light touches time, revealing that it does not flow the same everywhere. Light carries information, but only about what it interacts with. Light exists whether or not it is noticed, but it only becomes experience when something receives it. None of these ideas cancel each other out. They layer. The temptation, especially in science, is to look for a final description, a single sentence that explains what light really is once and for all, but light resists that kind of closure. Not because it is unknowable, but because it sits at the intersection of many rules at once: energy, motion, probability, interaction, geometry. It is not one thing pretending to be many. It is many things expressing one structure. That structure does not demand constant attention. It does not require belief. It simply operates. The universe uses light as one of its ways of staying connected to itself, and you are part of that network whether you think about it or not. Your eyes, when open, receive a narrow band of this activity and translate it into something meaningful. Color, shape, depth, movement. When your eyes are closed, light still exists, still moves, still touches surfaces and bodies, still participates in countless interactions that do not need to rise into awareness. Understanding this can feel grounding rather than unsettling. It means the world is not fragile. It does not depend on observation to hold together. It is active, structured, and patient. Light does not rush. Even at its immense speed, it follows rules that ensure consistency. It does not arrive early. It does not arrive late. It arrives when it arrives, carrying exactly the energy it carries, no more and no less. There is something steady about that. When people talk about light as illumination, they often mean clarity, knowledge, explanation. But light does not flood everything with answers. It reveals selectively. It highlights some structures and leaves others hidden. It gives enough information to navigate, not enough to overwhelm. This selective quality mirrors understanding itself. You never hold all of reality in your mind. You hold enough to function, to wonder, to rest. The exploration of light shows that not knowing everything is not a failure. It is a boundary condition. Light itself has limits, and those limits shape what kind of universe this is. A universe where information travels, but not infinitely fast. Where interactions are precise, but outcomes are probabilistic. where structure exists without needing constant confirmation. This kind of universe leaves room for stability and change at the same time. As you sit with this, the glow around you may feel a little different. Not brighter, not dimmer, just quieter. Less like a tool and more like an environment. Light as something you are inside, rather than something you look at. The surfaces in the room are not producing colour on their own. They are participating in exchanges. The air is not empty. It is full of passing signals. The space between objects is not nothing. It supports movement, interaction, and connection. None of this requires effort to maintain. It is already happening. Understanding light does not pull you away from rest. It can support it. There is no need to keep thinking actively. The ideas can remain present without being worked on, the way background light remains present without demanding focus. Even the most complex descriptions of light reduce in practice to something very simple. Energy moves, interactions happen, structures persist long enough to matter. You do not need to picture photons or fields to benefit from their existence. You already do. This perspective can soften the urge to resolve everything. Some questions are meant to remain gently open, not because they lack answers, but because their answers are distributed across many layers of understanding. Light is like that. It is not a single answer. It is a set of relationships that hold consistently, and those relationships are stable. They do not depend on your memory. They do not require vigilance. They do not change because you stop thinking about them. The universe does not forget how light works when you rest. As the pace of thought slows, it becomes easier to notice how little is required of you right now. You're not responsible for maintaining coherence. You're not responsible for understanding everything correctly. You're simply present in a system that continues on its own. Light continues to arrive. Energy continues to move. Time continues to unfold in its uneven way. Space continues to hold patterns and distances. None of this needs supervision. This can be reassuring. The question that started this journey, what is light made of, no longer needs to be answered directly. It has been approached from many angles. It has been loosened from rigid expectations. What remains is a sense of structure rather than a definition. Light is made of energy, organized in specific ways. It is made of interactions that occur in discrete steps. It is made of fields that support motion without substance. It is made of rules that connect space, time, and change. And it is made of relationships that do not require awareness to exist. That is enough. There is no need to conclude anything here. No need to summarize or wrap up. Light does not conclude. It continues. It reflects. It scatters. It passes through. It is absorbed and re-emitted, endlessly reshaping without ever stopping. Understanding can do the same. It does not have to finish. It can simply rest. So you can let the ideas remain where they are, loosely held, not demanding further work.